trip supplies. I'm off.
That's more than enough of theory for this topic, so let's do some calculations. Exercise C. What are the frequencies of 80-meter wavelength radio wave and an X-ray wavelength of 5.5 or 55 picometers? So all electromagnetic waves obey the given equation where speed of light equals wavelength times the frequency, and we are solving for frequency. So frequency is speed of light divided by the current wavelength, and in A the frequency is speed of light 3 times 10 to the 8 meters per second divided by 80 meters. This gives a frequency of 3.8 times 10 to the 6 1 over s, which is same as 3.8 megahertz. And B, for the X-ray, the frequency would be 3 times 10 to the 8 meters per second divided by the wavelength, which is very short, 5.5 times 10 to the minus 11 meters, and correspondingly the frequency is very high, about 5.5 times 10 to the 18 hertz. In exercise F, we can compare the speed of sound and the speed of light in terms of time. So if your voice traveled from as a sound wave, how long would it take to go from New York to London? So the time would be the distance divided by the velocity of the sound, which is about 5,600 kilometers divided by 340 meters per second. That gives about 16,500 seconds, which is roughly 4.5 hours. On the other hand, electromagnetic wave will cover the same distance in about 0.02 seconds. If we don't have direct link on the surface of the Earth from New York to London, and we would have to use satellites, for example, usually the communication satellites are about 36,000 kilometers from Earth, because then that's where they stay stationary relative to any given point on the surface. So communicating between two satellites or from, first of all, or we can do this with one satellite only. So from New York to the satellites, and then from New York back to London. In this case, we would have to cover a distance about 72,000 kilometers, and in that case, the time would be about 0.25 seconds. So this is already a noticeable delay if you're having a conversation with somebody. If we continue our little thought experiment by thinking about when we go to Mars one day, for example, the distance between Earth and Mars can be as large as 400 million kilometers. And in that case, the time delay for an electromagnetic wave would be 20 minutes one way. So that renders all the communications or real-time communications useless. So although speed of light is remarkable, it definitely has its limitations too. And we don't have to venture that far, even in our own solar system, to encounter them.
And the girls on the bus kept on laughing at us as we rode on 10 down to Venice again.